Regents Exam, Algebra I, August 2016, Problem number 1. The graph below shows the distance in miles, m, hiked from a camp in h hours. Which hourly interval had the greatest rate of change? In this problem, we are provided with a miles versus hours graph, with miles represented along the y-axis and hours represented along the x-axis. We are asked to determine the interval in which the hiker had the greatest rate of change. In other words, we are asked to determine the interval in which the hiker had the greatest velocity. Recall that the slope of a line can be used to represent a rate of change. In this problem, we have various intervals with distinct slopes. Let's go ahead and label each of the 6 points with a letter, as follows. Now let's go ahead and find the slope between each interval. Recall that the slope of a line can be calculated by dividing the rise, the change in y, with the run, the change in x. The slope for the interval between point A and point B is equal to 2 over 1, which simplifies to 2. The slope between point B and point C is equal to 1.5 over 1, which simplifies to 1.5, or 3/2. The slope between point C and point D is equal to 1 over 1, which simplifies to 1. The slope between point D and point E is equal to 0.5 over 1, which simplifies to 0.5, or 1/2. And the slope between point E and point F is equal to 0 over 1, which simplifies to 0. The largest or steepest slope is going to be the interval between point A and point B, which corresponds to the time interval between 0 and 1 hour. So option number 1 is the final answer. Regents Exam, Algebra I, August 2016, Problem number 2. The solution of an equation with 2 variables, x and y, is... In this problem, we need to determine which of the 4 statements given is true. We can figure out this problem by systematically going through each of the possible answers and logically determine which one is correct, or, at the very least, completes the statement. Let's start with the first option. The set of all x values that make y equal to 0. Recall that an equation is a mathematical statement that says that 2 expressions are equal to one another. When determining if 2 expressions are equal to one another, we check to make sure that the left-hand side of the equation is equal to the right-hand side of the equation. If both the left and right-hand side match, then the equation is true. If the left-hand side of the equation does not match the right-hand side of the equation, then the equation is false. The set of numbers that makes an equation true are referred to as solutions of the equation. Graphically, an equation with 2 variables can be represented by a curve in a Cartesian or xy coordinate system. When the equation is represented in this fashion, any point with coordinates xy that is located on the curve is said to be a solution to the equation. The first option for our answer reads, the set of all x values that make y equal to 0. Graphically, this represents all the points located on the curve of the equation that crosses the x-axis. In other words, these points are the x-intercepts of the equation. Although this is technically a solution to the equation, since the point is located on the curve and also makes the equation true, this is a particular solution from the many other solutions that this equation possesses. So the first option is not completely accurate. The second option is very similar to the first option. In this case, the statement reads, the set of all y values that make x equal to 0. Graphically, this will represent all the points where the equation of the curve crosses the y-axis. In other words, these points are the y-intercepts of the equation. Again, similar to the first option, there are many more solutions than just these particular set of points. Option 3 reads, the set of all ordered pairs xy that make the equation true. This statement says that the solution to an equation is going to be the set of all points xy that make the equation true. In other words, the set of all points that are located on the curve of the equation. This statement accurately describes the definition of a solution to an equation, so option 3 seems to be the correct answer. Before we decide to choose this option as our answer, let's take a look at option 4. This option reads, the set of all ordered pairs xy where the graph of the equation crosses the y-axis. This statement is essentially the same as that of option 2. It is stating that the solution to an equation are the y-intercepts. Again, these are not the only points that make the equation true. You also have all the other points located on the curve of the equation. So option 3 fits this definition. Regents Exam, Algebra I, August 2016, Problem number 3. Which statistic cannot be determined from a box plot representing the scores on a math test in Mrs. DeRiddler's algebra class? Recall that a box plot, also known as a box and whisker plot, splits a dataset into quartiles, separating the data into 4 parts. The body of the box plot consists of a rectangular box, hence the name, which starts from the first quartile, Q1, and ends at the third quartile, Q3. Within the box, a vertical line is drawn at the second quartile, Q2, which represents the median of the data set. The median is a middle number when the data set is arranged from the smallest to largest value. In addition to the box, 2 horizontal lines called whiskers extend from the left and right side of the box. The left whisker starts from the first quartile, Q1, and extends to the smallest or minimum value of the data set. The right whisker starts from the third quartile, Q3, and extends to the largest or maximum value of the data set. For this problem, we need to choose the option with the statistic that cannot be determined from a typical box plot. Let's systematically go down the options. Option 1 reads, the lowest score. The lowest score is also known as the minimum value. This statistic can be obtained from the box plot. It will be the point located at the beginning of the left whisker. The second option reads, the median. This statistic can also be found from the box plot. This will be the value located on the second quartile. Option 3 reads, the highest score. This statistic is also known as the maximum value, and this statistic can be found in a box plot. It will be the value located at the end of the right whisker. Option 4 reads, the score that occurs most frequently. A typical box plot does not keep track of the frequency in which the numbers in a dataset appear, since the box plot only divides the data into quartiles. So option 4 is our answer, since this statistic cannot be obtained from a box plot representing the scores on a math test. Regents Exam, Algebra I, August 2016, Problem number 4. Which chart could represent the function f of x equals negative 2x plus 6? Here we are given charts that contain a set of points. We need to choose the chart that contains the points that represents the function f of x. We can determine this in a couple of ways. We can go ahead and systematically go through every single point for each option and check to see if the point makes the equation true. For example, the chart from option 1 contains 4 points. We will need to systematically go through each point and make sure that every single point yields a true statement when they are substituted into the function. The first point, 0, 6, yields a true statement. So far, so good. Now we need to test the other 3 points. The second point yields a false statement. The false statement automatically makes the chart from option 1 incorrect. Remember, we need every single point on the chart to yield true statements when substituted into the function. As soon as one point yields a false statement, the rest of the points on the chart are automatically eliminated. Now, we can go ahead and potentially test 3 more points, one from each remaining chart if we are lucky, or do it 12 more times if luck is not on our side. We need to figure out a way to determine the answer more efficiently. Notice that the function represents the equation of a line of the form y equals mx plus b, where m represents the slope of the line and b represents the y-intercept. In this problem, the slope is equal to -2, and the y-intercept is equal to +6. This means that the points on the chart need to be consistent with this slope and y-intercept. In other words, the points in the chart need to have a rise over run equal to -2 and have the point 0, 6 as one of its points. Looking at the options, we see that option 1 and option 4 contain the point 0, 6, so we should start analyzing these 2 charts first. We already eliminated option 1 because we tested a point that yielded a false statement. So let's move along to option 4. To confirm that this option is correct, we need to calculate the slope between 2 points and make sure that it is equal to -2. Using the value in the first row as 0.1 and the values of the second row as 0.2, we go ahead and calculate the slope between these 2 points. Simplifying the expression, we obtain -2 for the slope. We now have enough evidence to confidently conclude that the chart from option 4 represents the function of f of x. Regents Exam, Algebra I, August 2016, Problem number 5. If f of n equals the quantity n minus 1 squared plus 3n, which statement is true? Here we are provided with the function f of n, and we need to choose the option that yields a true statement. The best way to approach this problem is to systematically go through every option until we find our answer. Notice that for each option, we are given the input, or n value, as well as the result, or output, when the value of n is substituted into the function and evaluated. Let's start with the values from option 1. Here, the value of n is 3, so we substitute this value into the function, making sure we use parentheses when we substitute the variable n with 3, as follows. Then, we proceed by simplifying the expression, making sure we follow the order of operations. In this case, we need to simplify the expression inside the parentheses first, then we square the result and add it to the result of the product. Doing that, we obtain the following value. Notice that this value does not match the output from option 1. Hence, this option is incorrect, since it did not yield the same output. Let's try the value of option 2. Here, we substitute the function with -2. Once again, making sure we use parentheses when substituting the variable with -2. Simplifying the expression, we obtain the following output. Notice that this value matches the output of option 2. So we conclude that option 2 yields a true statement. Regents Exam, Algebra I, August 2016, Problem number 6. The table below shows 6 students' overall averages and their averages in their math class. If a linear model is applied to these data, which statement best describes the correlation coefficient. Recall that the correlation coefficient measures the strength and direction of a relationship between two variables. In the case of a linear model, the linear correlation coefficient R is a number between -1 and 1 inclusive. The positive and negative signs are used for positive linear correlations and negative linear correlations, respectively. If the two variables, x and y, have a strong positive linear correlation, the value of R will be very close to +1. If R is exactly equal to 1, then this indicates a perfect positive fit, and the data will lie on a straight line with a positive slope. On the other hand, if two variables, x and y, have a strong negative linear correlation, the value for R will be very close to -1. If R is exactly equal to -1, then this indicates a perfect negative fit, and the data will lie on a straight line with a negative slope. Very rarely do linear models have an exact R value of +1 and -1, and will usually have values between -1 and +1. If R happens to be equal to 0, then there is no linear correlation, or if it is very close to 0, then we say that the data has a weak linear correlation. For example, the data can be random or have a nonlinear relationship between the two variables x and y. One way to determine the correlation coefficient is to plot the points in a coordinate plane and look at the pattern formed by the data, and determine the value of the correlation coefficient by inspection. If the data seems like it lies on a positive sloping straight line, then the correlation coefficient will be very close to +1. If the data seems like it lies on a negative sloping straight line, then the correlation coefficient will be very close to -1. A second way to approach the problem is by using a graphing calculator. Graphing calculators usually have statistic programs that can calculate the value for the correlation coefficient. Usually, this is done by first creating a chart or list that contains the values for one variable, in this case, the overall student average, and a second list that contains the values for the second variable, in this case, the math class average. Once the list is created, you can use a linear regression program to generate a regression equation, which will also generate the value for the correlation coefficient R. Please read your calculator manual or look up the steps required to use this feature on the graphing calculator that you will be using for your test. Usually, the program can be found under the name linreg. By using linreg, we obtain a correlation coefficient approximately equal to +0.92. By using this value for the correlation coefficient, along with the plot of the points we drew earlier, we can conclude that option 2 is the best choice. Regents Exam, Algebra I, August 2016, problem number 7. What is the solution to 2h plus 8 is greater than 3h minus 6? In this problem, we essentially need to find the solution to the inequality. Recall that problems involving inequalities can be solved similarly to equations. We need to apply various properties of inequalities to isolate the variable. Let's start by collecting like terms. So we first subtract 8 from both sides of the inequality, as follows. Then we go ahead and subtract 3h from both sides of the inequality and simplify. Lastly, we need to make the variable positive, so we either divide or multiply both sides of the inequality by -1. Remember to flip the inequality symbol anytime you multiply or divide an inequality by a negative number. Flipping the inequality symbol and simplifying, we obtain h is less than 14. We can also write this answer as 14 is greater than h. Both expressions are equivalent. The option choices could have either of these two equivalent forms as an answer. So if you can't find an answer, it could mean that it is written in an alternative form, with the value written first, followed by the variable. Typically, the solution to inequalities are written with the variable first, followed by the value. Looking at the options, we see that option 1 is the solution. Regents Exam, Algebra I, August 2016, problem number 8. Which expression is equivalent to 36x squared minus 100? In this problem, we need to determine which of the 4 options given is equivalent to 36x squared minus 100. Notice that the possible answers are all written in factored form. We can figure out this problem by systematically applying the distributive property for each expression given until we find a match. If we are lucky, we only need to do this once, and if luck is not on our side, we may have to attempt this 4 times max. An alternative way to find the answer is to rewrite the given polynomial by factoring it. We can start by first identifying the greatest common factor between all the terms in the polynomial. We first need to identify a common factor between the coefficients of the terms, in this case, 36 and 100. The common factor between 36 and 100 can be found by inspection, or you can write the prime factorization of each number and determine the factors that both 36 and 100 have in common. The prime factorization of 36 is 2 times 2 times 3 times 3. The prime factorization of 100 is 2 times 2 times 5 times 5. Both numbers have 2 times 2 in common, so the greatest common coefficient is 4. Next, we need to determine if both terms have a common variable. The first term has x squared, and the second term does not have a variable, so both terms do not have a common variable. So the greatest common factor between these 2 terms is going to be 4. Factoring out 4 from both terms, we obtain the following expression: 4 times the quantity 9x squared minus 25. Notice that none of the answers match this expression. This means that we need to continue factoring the polynomial. Taking a look at the quantity 9x squared minus 25, we should be able to identify this expression as a special factoring type, particularly a difference of squares. Recall that a difference of squares, a squared minus b squared, factors into the quantity a minus b times the quantity a plus b. At first glance, the expression 9x squared minus 25 might not seem to match this special factoring formula, but by rewriting the first term as the quantity 3x squared and the second term as 5 squared, we can now clearly see that this expression is a difference of squares, with the value of a from the formula being equal to 3x, and the value of b in the formula being equal to 5. Factoring out this expression, we obtain the following: 4 times the quantity 3x plus 5 times the quantity 3x minus 5. Looking at the answers, we see that option 2 is the equivalent expression. Regents Exam, Algebra I, August 2016, problem number 9. Patricia is trying to compare the average rainfall of New York to that of Arizona. A comparison between these 2 states for the months of July through September would be best measured in. This problem requires us to choose the best answer that completes the statement above. In this case, we want to select the appropriate units to compare the average rainfall between New York and Arizona. The best way to figure out this problem is to systematically go through all the options. Option 1 uses feet per hour. Option 2 uses inches per hour. Option 3 uses inches per month. And option 4 uses feet per month. In the statement above, the student is trying to measure the average rainfall for the months of July through September. Since we want to collect data for each month, it makes sense to use months for our time interval, and not hours. So we can eliminate option 1 and option 2. Now we need to decide if we would use inches or feet. Recall that 1 foot is equivalent to 12 inches. This means that 1 foot is larger than an inch. If we're going to be measuring the amount of rainfall, we should use the smallest unit. This way, we can obtain more accurate measurements. In this case, we will use inches, which corresponds to option 3. So we should measure the average rainfall in inches per month. Regents Exam, Algebra I, August 2016, problem number 10. Which function defines the sequence -6, -10, -14, -18, and so on, where f of 6 is equal to -26? In this problem, we are asked to determine which function corresponds to the given sequence, knowing that f of 6 is equal to -26. We can figure out this problem by systematically going through each of the given functions and evaluate them at x equals 6. The result should give us -26. Evaluating the first function at x equals 6, we obtain -26, and bingo, we figured it out on the first attempt. We could have attempted it 4 more times until we found the correct answer, but we got it on the first try. Now, if you do not want to solve the problem by using the systematic approach, we can also figure out the problem by analyzing the sequence. Notice that the sequence is consistently decreasing by -4. This means that the sequence has a common or first difference of -4. When the first difference of a sequence is consistent, then the sequence is linear and has the same form as the slope-intercept form of the equation of a line. In this case, y equals mx plus b. Since the common difference is -4, this will correspond to the slope of the function that defines the sequence. Looking at the options, we see that option 1 is the only function that has a slope of -4. So we can conclude that this function defines the decreasing sequence with the common difference of -4. Regents Exam, Algebra I, August 2016, problem number 11. Which function has the greatest y-intercept? In this problem, we are provided with 4 functions, each one expressed in a distinct form. We need to determine which of these functions has the greatest y-intercept. For this type of problem, we have no other choice but to systematically go through each option and make a decision only after we have analyzed all the possible answers. Let's start with the first option. Here we have f of x equals 3x. This is equivalent to y equals 3x. Recall that the equation of a line in slope-intercept form is y equals mx plus b, where m represents the slope and b represents the y-intercept. Comparing both functions, we see that f of x equals 3x has a slope of 3 and a y-intercept of 0. Alternatively, we could have figured out the y-intercept by setting x equal to 0 and simplifying the expression or solving for f of x or y. Recall that the y-intercept of a function is the point where the function crosses the y-axis and has an x-coordinate equal to 0. Taking a look at option 2, we see that we have the standard form of the equation of a line of the form ax plus by equals c. We can determine the y-intercept by rewriting the function into the slope-intercept form by solving for y. So we first subtract 2x from both sides of the equation. We then divide both sides of the equation by 3, making sure we divide both terms on the right side of the equation. Doing that, we obtain the following alternative form of the function: y equals negative 2/3 x plus 4. Comparing this function with the slope-intercept form of the equation of a line, we see that the y-intercept is equal to 4. Alternatively, we can also determine the y-intercept by setting the variable x equal to 0 and solving for y. Doing that, we also obtain 4 for the y-intercept. For option 3, we are not provided with a function, but we are provided with a description of the line. In this case, the line has a slope of 2 and passes through the point 1, negative 4. In order to determine the y-intercept, we can make use of the point-slope form of the equation of a line to do just that. The point-slope form has the following form: y minus y sub 1 equals m times the quantity x minus x sub 1, where m represents the slope and x sub 1 and y sub 1 represent the points x and y coordinates, respectively. Substituting the value for the slope for m and the points coordinates for x sub 1 and y sub 1, we obtain the following. Next, we need to solve for y and rewrite the equation in slope-intercept form. So we distribute the slope and then subtract 4 from both sides of the equation, obtaining the following function: y equals 2x minus 6. We can now clearly see that this line has a y-intercept equal to negative 6. Lastly, we need to find the y-intercept of option 4. Here, we're given a graphical form of the equation of a line. We can quickly determine the y-intercept by locating the point where the function crosses the y-axis, or in this case, f of x. Locating the point, we see that this occurs at the point 0, 5. So the y-intercept is equal to positive 5. Comparing the y-intercept of all 4 options, we see that the greatest y-intercept is 5, so option 4 is the answer. Regents Exam, Algebra I, August 2016, problem number 12. What is the product of the quantity 2x plus 3 and the quantity 4x squared minus 5x plus 6? In this problem, we are asked to determine which of the given polynomials is equivalent to the product of the binomial and trinomial. The quickest way to figure this out is by directly finding the product between the binomial and trinomial, since the individual terms of the polynomials given in the options are nearly identical to one another. With the exception of the sign, some terms are positive and other terms are negative. Because of this small distinction, it will be best to directly carry out the product. In other words, to multiply the polynomials, we need to apply the distributive property. This is similar to when we FOIL two binomials with one another. In this case, we are distributing a binomial with a trinomial. So starting with the first term of the binomial, in this case 2x, we go ahead and multiply this term with every single term of the trinomial, obtaining 8x cubed minus 10x squared plus 12x. Next, we do the same with the second term of the binomial, in this case 3, and distribute it to each of the terms of the trinomial. Doing that, we obtain 12x squared minus 15x plus 18. Next, we need to simplify the polynomial by collecting like terms and writing the polynomial in standard form. The terms negative 10x squared and positive 12x squared simplify to 2x squared. The terms positive 12x and negative 15x simplify to negative 3x. In the end, we obtain the following polynomial: 8x cubed plus 2x squared minus 3x plus 18. Taking a look at the options, we see that option 3 is a perfect match, so option 3 is our answer. Regents Exam, Algebra I, August 2016, problem number 13. The height of a rocket at selected times is shown in the table below. Based on these data, which statement is not a valid conclusion? In this problem, we are provided with 4 statements, and we need to determine which statement is not valid. The best way to approach this problem is to systematically go through all the possible options and make a decision only after we have analyzed each of the statements. Let's start with option 1. The statement reads, the rocket was launched from a height of 180 feet. Let's take a look at the table and find proof that backs up this statement. The data table contains 2 distinct measurements, time in seconds and height in feet. The moment when the rocket launches, the timer begins, so at 0 seconds, we see that the rocket was at a height of 180 feet, so option 1 is a valid conclusion. Option 2 reads, the maximum height of the rocket occurred 3 seconds after launch. Taking a look at the data, we see that the maximum height was 324 feet, and it occurred 3 seconds after launch, so option 2 is a valid conclusion. Option 3 reads, the rocket was in the air approximately 6 seconds before hitting the ground. Taking a look at the height 6 seconds after launch, we see that the height is equal to 180 feet. This means that the rocket is still in the air at this time. After 7 seconds, we see that the rocket is still in the air at 68 feet. It seems that this statement is not a valid conclusion, since none of the data seems to support it. Let's take a look at the last statement before we decide to choose our answer. Option 4 reads, the rocket was above 300 feet for approximately 2 seconds. Let's find all the times when the rocket was above 300 feet. Looking at the data, we see that this occurs during the 2nd, 3rd, and 4th second after launch. This interval spans 2 seconds, so this statement is valid. Having analyzed all 4 options, we can conclude that option 3 is not a valid conclusion. Regents Exam, Algebra I, August 2016, Problem number 14. A parking garage charges a base rate of $3.50 for up to 2 hours, and an hourly rate for each additional hour. The sign below gives the prices for up to 5 hours of parking. Which linear equation can be used to find x, the additional hourly parking rate? In this problem, we need to determine which linear equation can be used to solve for the hourly rate charged after 2 hours. Notice that the parking garage charges a base rate of $3.50 for up to 2 hours. So if you stay for an hour less than 2, you will still be charged $3.50. If you happen to stay beyond 2 hours, then the parking garage will start charging you a parking rate for every hour after 2 hours. We can determine the additional hourly parking rate by taking a look at the prices. The base price for 2 hours is $3.50, and the price for the 3rd hour is $9. This is a $5.50 increase from the 2nd to the 3rd hour. The price increase from the 3rd to the 4th hour is also $5.50. The same price also increases from the 4th to the 5th hour. We now know that the hourly parking rate after the first 2 hours is $5.50 per hour. Now we need to determine which of the 4 linear equations can be used to solve for x, where x represents the additional hourly parking rate, in this case, $5.50. We can determine this by systematically solving for x in each linear equation until we find a match. We can also analyze each of the equations by substituting the known hourly rate, in this case $5.50, into the equations, and checking to see if the equation results in a true statement. For example, the first option has the linear equation 9 plus 3x equals 20. If x represents the hourly parking rate after the 2nd hour, then 3 times $5.50 plus 9 should equal 20. But notice that the left side of the equation does not simplify to 20. This results in a false statement. so this equation cannot be our answer. Doing the same for option 2, we see that replacing x with 550 also gives us a false statement. Continuing with the equation of option 3, we see that this equation gives us a true statement, so we can conclude that option 3 is our answer. Regents Exam, Algebra I, August 2016, problem number 15. Which function has a constant rate of change equal to -3? In this problem, we are asked to determine which of the four functions has a constant rate of change equal to -3. In other words, we need to figure out which option has a consistent slope of -3. Notice that each option represents a function in a distinct way. To figure out this problem, we can systematically determine the slope for each of the given functions. Let's start with option 1. Here, we have a function represented in tabular form. Each row represents an ordered pair, or point, of the function. We can determine the rate of change, or slope, of the function by calculating the rise over the run, or the change in y over the change in x. We do this by choosing 2 points and subtracting the y coordinates, and dividing the result with the difference of the point's x coordinates. We need to make sure that this slope is consistent, no matter which 2 points we decide to use for our calculation. Using the first 2 points, we compute the slope, which ends up being equal to 3/1, which simplifies to +3. Since the slope is not equal to -3, we do not need to check the rest of the points for this option, since the slopes have to be consistent regardless of the points chosen. So we can eliminate this option and move along to the next one. For option 2, we once again have a function represented as a set of ordered pairs or points. Similar to option 1, we want to compute the slope between 2 points and check to see if it's equal to -3. Using the first 2 points, we compute the slope, which simplifies to -3. It seems that we found our answer, but we need to make sure that this slope is consistent, regardless of which 2 points we choose. So let's find the slope between 2 other points, in this case, the second and third point. Computing the slope, we see that we obtain a totally different slope. Since this slope is not equal to -3, we do not need to bother checking the rest of the points. We can conclude that this option is not our answer. Moving along to option 3, we see that this function is represented in graphical form. So we can determine the slope by calculating the rise over run between 2 points. In this case, we can use the y-intercept, which is equal to 0,3, and the point 1, 1. Computing the slope, we obtain -2, which is not equal to -3, so we conclude that this option is not our answer. From the process of elimination, we know that option 4 should be our answer, but let's make some calculations just to make sure. The function from option 4 is an equation of a line, so we can determine the slope by rewriting the equation in slope-intercept form. So we go ahead and divide the function by 2. We then simplify both sides of the equation. Doing that, we obtain the following expression. Writing the equation in slope-intercept form allows us to clearly see that the slope of this linear equation is equal to -3, so option 4 is our answer. Regents Exam, Algebra I, August 2016, problem number 16. Kendall bought X boxes of cookies to bring to a party. Each box contains 12 cookies. She decides to keep 2 boxes for herself. She brings 60 cookies to the party. Which equation can be used to find the number of boxes X Kendall bought? In this problem, we are asked to determine which of the 4 equations given can be used to determine the number of boxes that Kendall bought, knowing that each box contains 12 cookies. She kept 2 boxes for herself, and, in the end, she brings a total of 60 cookies to the party. The best way to solve this problem is by translating the word problem into an equation and matching our equation with one of the options. Let's first determine what the unknowns are. According to the problem, we want to determine the number of boxes that Kendall bought. So this will be our unknown. So we will use the variable x to denote the number of boxes. Next, let's determine what the facts of the problem are. We know that each box contains 12 cookies each. We also know that Kendall kept 2 boxes for herself. The last fact is that Kendall ends up bringing 60 cookies to the party. Using these facts, let's start writing an expression for our equation. By using fact number 1, we know that each box holds 12 cookies. So if she bought 2 boxes, she would have 24 cookies. If she bought 3 boxes, she would have 36 cookies, and so on. In general, if she bought x boxes, then she would have 12 times x, or 12x cookies. Using the second fact, we know that she kept 2 boxes for herself. This corresponds to 24 cookies. Lastly, we can combine the first fact and the second fact by using the third and final fact. In this case, she brought a total of 60 cookies to the party. We can combine the results of the first fact, in this case 12x cookies, and subtract the total number of cookies from the second fact, in this case 24 cookies. And we should obtain the total number of cookies she brought to the party, in this case 60 cookies. The final equation is equal to 12x minus 24 equals 60. Looking at the options, we see that option 3 is our answer. Regents Exam, Algebra I, August 2016, problem number 17. The table below shows the temperature, T of M, of a cup of hot chocolate that is allowed to chill over several minutes, M. Which expression best fits the data for T of M? In this problem, we are asked to determine which of the 4 expressions given best fits the data from the table. Since the question is asking us to determine which expression best fits the data, we need to analyze the data in the table, along with the expressions provided. Notice that the expressions for all 4 options represent exponential functions. Recall that an exponential function has the following form. F of t equals 8 times the quantity 1 plus or minus r raised to the power of t, where a is greater than 0. There are 2 types of exponential functions, growth and decay. If the quantity inside the parentheses, which represents the base of the exponent, is a number equal to or greater than 1, then the function represents an exponential growth function. On the other hand, if the quantity inside the parentheses is a number between 0 and 1, then the function represents an exponential decay function. If r represents the rate of growth expressed as a decimal, then we would use the exponential function with the quantity 1 plus r to model an exponential growth function. If r represents the rate of decay expressed as a decimal, then we would use the exponential function with the quantity 1 minus r to model an exponential decay function. In both exponential models, a represents the original or initial value and t represents time. Notice that all the options have 150 as the original or initial value, so we can't determine our answer solely based on the original or initial value. We need to figure out a different way to determine the expression that matches the data. With this in mind, let's analyze the data and figure out whether the data can be modeled as an exponential growth or exponential decay function. Notice that the temperature is going down as the number of minutes pass by. This is characteristic of an exponential decay function. As time progresses, the temperature of the hot chocolate becomes colder. With this observation, let's determine which options represent exponential decay functions. We're looking for functions that contain a number between 0 and 1 for the base of the exponent. The first and third options have a value of 0.85 for the base of the exponent. So these options represent exponential decay functions. Options 2 and 4 have a value of 1.15 for the base of the exponent. So these expressions represent exponential growth functions. So we can eliminate these two options. Now we need to determine which of the exponential decay functions best fits the data. We can figure this out by selecting an ordered pair from the data and substitute it into the expression and check to see if it yields a true statement. Choosing the point 0, 150 and testing the expression from the first option, we go ahead and substitute m with 0. Make sure you follow the order of operations. We first need to simplify the exponent, then multiply the result. We also need to remember that a number other than 0 raised to the power of 0 is equal to 1. Simplifying the expression, we obtain 150. So this point yields a true statement. So we can conclude that option 1 is our answer. Regents Exam, Algebra I, August 2016, problem number 18. As x increases beyond 25, which function will have the largest value? In this problem, we are provided with 4 separate functions, and we are asked to determine which of the 4 functions will have the largest value when x is greater than 25. We can figure out this problem in a couple of ways. We can graph every single function in a graphing calculator and determine by inspection which graph is the largest when x is greater than 25. We can also evaluate each of the functions with a number greater than 25 and choose the option that has the largest output or y value. If we were to graph each of the given functions on the same graph, we would obtain the following. Notice that the function of the first option has the largest y value when x is greater than 25, followed by the function of the fourth option, then the function from the third option, and the smallest y value is from the function of the second option. So if all 4 functions had a race, then the exponential function would be in the lead when x is greater than 25. Just to make sure, let's evaluate each of the functions when x equals 26. Evaluating each of the given functions, we obtain the following y values. Once again, notice how the exponential function has the largest y value when compared to the rest of the functions. With that said, we can conclude that option 1 is our answer. Regents Exam, Algebra I, August 2016, problem number 19. What are the solutions to the equation 3x squared plus 10x equals 8? In this problem, we are asked to determine the solutions of the quadratic equation. We can find the solutions in a couple of ways. We can go ahead and graph the function and find the solutions by using a graphing calculator. Or we can attempt to factor out the quadratic function and use the zero product property to find the solutions. Let's first solve the problem by graphing the function. We can find the solutions by graphing in a couple of ways. We can graph 2 distinct functions. The functions can be obtained by using the expression on the left and right side of the equation. In this case, we can graph the function y equals 3x squared plus 10x and graph the function y equals 8 on the same graph. Doing that, we obtain the following. Now we need to determine where the first function intersects the second function. We can determine this by inspection. Looking at the graphs, we see that both functions intersect at the point 2/3, 8, and -4, 8. We can also find the solutions by rewriting the equation and setting it equal to 0. So we subtract 8 from both sides of the equation and simplify. We then graph the function 3x squared plus 10x minus 8. The solutions to the equation will be the points where the function crosses the x-axis. Graphing the function, we see that this function crosses the x-axis at the same points as the previous graph. Either of the two methods will work if you're trying to find the solutions of an equation. You can graph the expressions on the left and right side of the equation and find the points where both curves intersect. Or you can set the equation equal to 0 and find the points where the curve crosses the x-axis. An alternative way of finding the solutions of a quadratic equation is by factoring. We start by rewriting the equation by setting it equal to 0. So we subtract 8 from both sides and simplify. Notice that we have a quadratic trinomial with a leading coefficient that is greater than 1. So we will use the method of decomposition and grouping to factor out the quadratic trinomial. We first need to multiply the constant term, in this case, -8, by the leading coefficient, in this case, +3, obtaining -24. We then need to find two integers that multiply to -24 and whose sum is the coefficient of the linear term, in this case 10. We can systematically go through all the possible combinations until we find a perfect match. The integers that multiply to 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. We can obtain -24 by making one of the integers negative. Since we want the sum to add up to +10, we should use the integers 2 and 12 and make 2 a negative integer so that we obtain +10 when we add the integers together. Now that we have found our integers, we proceed with the decomposition step and decompose the linear term, in this case 10x, as a sum of these two integers, in this case -2x and +12x. Now we proceed with the grouping step. So we're going to group a decomposed term with a non-decomposed term. In this case, we will group together 3x squared and -2x, and group together 12x and -8. Next, we factor out the GCF from each grouping. For the first grouping, it is x, and for the second grouping, it is 4. Doing that, we obtain the following. Notice that we now have a common factor between both terms. In this case, the quantity 3x minus 2, this is a good sign. The presence of a common factor indicates that we are on the right track. The next step is to factor out this quantity from both terms as follows. We now have the complete factored form of the quadratic trinomial. The final step is to use the zero product property, set each factor equal to 0, and solve for x. Doing that, we obtain x is equal to 2/3 and -4. Looking at the options, we see that the first option is a perfect match, so option 1 is our answer. Regents Exam, Algebra I, August 2016, problem number 20. An online company lets you download songs for 99 cents each after you have paid a $5 membership fee. Which domain would be the most appropriate to calculate the cost to download songs? In this problem, we need to determine the type of numbers that our variable is allowed to have in order to appropriately calculate the cost to download songs. Let's first determine the variable expression that can be used to calculate the total cost to download songs, and then we will systematically go through the given options to see which one would be the most appropriate. According to the problem, there is an initial membership fee of $5, which has to be paid before you even start to download songs. Once you pay the membership fee, then you will be allowed to download songs for 99 cents each. So if we let x represent the number of songs, then the total cost for downloading x number of songs will be given by the following expression: 5 plus 0.99x. This expression represents the total cost for downloading x number of songs. Now let's systematically go through the given options and determine which one would be the most appropriate. Option 1 reads, rational numbers greater than 0. Recall that the set of rational numbers consists of all the numbers of the form a over b, where a and b are integers, provided that b does not equal 0. The set of numbers includes numbers such as 1, 2, 3, as well as fractions such as 1/2, 3/2, and 1/8. If we allow the domain of x, the number of songs, to be the set of rational numbers greater than 0, then we would be able to purchase any multiple of a positive integer, such as 1, 5, or 20. This means that we can also purchase a fractional portion of a song, such as 1/2, 3/2, and 1/8. This is a problem since we do not usually buy half a song, or an eighth of a song. So this domain does not make sense. Option 2 reads, whole numbers greater than or equal to 1. This domain includes all the whole numbers greater than or equal to 1. This includes numbers such as 1, 2, 10, and 20. Since the domain consists entirely of whole numbers, there shouldn't be a problem assigning this domain to the possible values of x, the number of songs bought, since the whole numbers represent the purchase of a complete song, and not a fractional portion of it. It seems that this is our answer. Just to make sure, let's take a look at the remaining options. Option 3 reads, integers less than or equal to 0. This set will include numbers such as 0, -1, -5, and -20. The number 0 makes sense since you can decide not to buy a song. But the negative integers means that the online company will actually pay us 99 cents when we decide to purchase a song. So this domain makes no sense. Companies tend to take your money, not give you money. Option 4 reads, whole numbers less than or equal to 1. This is very similar to the set of numbers from option 3. As a result, this option will also make no sense for the domain of the variable x. Doing so would make the company pay us money for buying songs. In the end, the option that makes most sense is option 2, whole numbers greater than or equal to 1. And this is our final answer. Regents Exam, Algebra I, August 2016, problem number 21. The function f of x equals 3x squared plus 12x plus 11 can be written in vertex form as. In this problem, we need to determine which of the options is equivalent to the given quadratic function. We can figure this out in a couple of ways. We can expand and simplify each of the given options until we match the original function. If we are lucky, we can figure this out in one guess. If not, we might have to expand every single one of the expressions until we find a match. Alternatively, we can also figure this problem out by rewriting the original quadratic function into the vertex form. We accomplish this by completing the square, by making use of the quadratic and linear terms of the function. We start by grouping together the quadratic term and linear term, in this case 3x squared and 12x. Next, we factor out the coefficient of the quadratic term, in this case 3. Doing that, we obtain the following quadratic expression that has a leading coefficient of 1. Next, we need to complete the square with the terms inside the parentheses. Recall that we can complete the square by introducing a constant into the group expression so that it becomes a perfect square trinomial. This way, we will be able to factor it as a binomial squared. The constant that we need to introduce can be found by identifying the coefficient of the linear term of a quadratic expression written in standard form, in this case ax squared plus bx plus c, and dividing the coefficient of the linear term, in this case b, by 2, and squaring the result. For this problem, the linear term is 4, and we divide it by 2. We then take this result and square it. Doing that, we obtain 4. We now need to introduce this term into the group expression, making sure we also introduce the additive inverse, so that the sum reduces to 0. This way, we obtain an equivalent but modified function. Notice that if we introduce the constant 4 into the group expression, we would actually be introducing the constant 4 times 3, which is equal to 12. So we need to also introduce the additive inverse of 12 into the expression in order to maintain balance or equality. Doing that, we obtain the following. Next, we write the perfect square trinomial into its factored form, which ends up being equal to the quantity x plus 2 squared. We also need to simplify the constants. Doing that, we obtain -1. In the end, we have the vertex form of the quadratic function, in this case, 3 times the quantity x plus 2 squared minus 1. Looking at the options, we see that option 3 is a perfect match, so this is our final answer. Regents Exam, Algebra I, August 2016, problem number 22. A system of equations is given below. Which system of equations does not have the same solution? In this problem, we need to determine which of the given system of equations does not have the same solution as the system of equations x plus 2y equals 5 and 2x plus y equals 4. We can determine this in a couple of ways. We could graph every single system of equations and verify by inspection which system does not have the same solution as the other 3 options. This would take quite some time since we need to solve for y for each system and graph all 4 systems. We can also find the solution of the original system and test the solution for every single option. The option that does not yield a true statement for both equations would be our answer. This method will also take some time. An alternative approach would be to analyze each system and determine if each equation in the system is a constant multiple of a number. Recall that an equivalent system of equations can be obtained by just multiplying the entire equation by a constant. For example, if we take the original system and multiply the first equation by 3, we would obtain the following. This new system of equations would still have the same solution as the original system of equations. Notice that this system matches option 1. This means that both of these system of equations have the same solution. We are trying to find the system that does not have the same solution as the original system. Let's now analyze the system of the second option. Here, it seems that the first equation has been multiplied by a number. In this case, it has been multiplied by 4. So, if we divide the first equation by 4, we would obtain the exact same equation from the original system. This means that this system also has the same solution. Moving along to option 3, we see that the first equation is the same as the original system, but the second equation seems to be modified. Looking at the equation, we see that it has been multiplied by 3. This means that this system also has the same solution as the original system. By the process of elimination, we know that our answer has to be the system from option 4. But just to make sure, let's see why this system of equations does not have the same solution as the original system. Notice that the first equation seems to be okay. It matches the first equation of the original system, so this is not the problem. Looking at the second equation, we see that it seems to have been multiplied by 2, but if that was the case, the constant should be 8 and not 12. Since this equation cannot be obtained by multiplying the second equation of the original system by a single constant, we can conclude that this system will not have the same solution as the original system. So option 4 is our final answer. Regents Exam, Algebra I, August 2016, problem number 23. Based on the graph below, which expression is a possible factorization of p of x? In this problem, we need to determine which of the given options can be a possible factorization of the polynomial function p of x. We can determine this by analyzing the graph of the polynomial function. Recall that a polynomial function can be written in factored form, granted that it is factorable over the integers. Otherwise, it would be referred to as a prime polynomial. For example, the polynomial function x squared minus 5x minus 6 can be written in factored form as the quantity x plus 1 times the quantity x minus 6. The factored form of a polynomial can be used to identify the zeros or x-intercepts of the polynomial function. For example, this same polynomial would have one zero located at -1, 0, and another 0 located at +6, 0. We can also determine the factored form of a polynomial by using the graph of the polynomial. In this case, we would need to identify the zeros or x-intercepts of the graph, and then use the x-coordinates of the zero, and work backwards to construct the factor from which the zero was originally solved from. In this example, notice that the zero located at x equals -1 was obtained from the factor x plus 1, and the zero located at x equals +6 was obtained from the factor x minus 6. Notice that the x-coordinate of the zero switches signs when it is used to write the factor of the polynomial. With this in mind, let's take a look at the problem at hand. Notice that this polynomial crosses the x-axis 3 times. This occurs at the points -3, 0, +2, 0, and +4, 0. Using these zeros, we can go ahead and construct the factored form of the potential polynomial. The first zero, -3, 0, came from the factor x plus 3. The second zero, +2, 0, came from the factor x minus 2. And the last zero, +4, 0, came from the factor x minus 4. Looking at the options, we see that option 1 is a perfect match, so option 1 is our final answer. Regents Exam, Algebra I, August 2016, problem number 24. Milton has his money invested in a stock portfolio. The value, v of x, of his portfolio can be modeled with the function b of x equals 30,000 times 0.78 raised to the power of x, where x is the number of years since he made his investment. Which statement describes the rate of change of the value of his portfolio? In this problem, we need to determine how the value of a particular investment is changing every year. We can determine this by analyzing the function v of x. Notice that the function v of x represents an exponential function. Recall that an exponential function has the following form: a times the quantity 1 plus or minus r raised to the power of t. Here, a represents the initial amount. For this problem, the initial amount is 30,000, the initial investment. The quantity 1 plus or minus r represents the base of the exponential function. In this quantity, r represents either the rate of growth or rate of decay, expressed as a decimal. When the base is a number greater than 1, then the function represents an exponential growth function. If the base is a number between 0 and 1, the function represents an exponential decay function. The function v of x has a base equal to 0.78, a number between 0 and 1. This means that this function is modeling an exponential decay function. So the initial investment is losing value with time. Looking at the options, we can go ahead and eliminate options 3 and 4, since these options describe an investment that is growing with time. With those options eliminated, we now need to determine if the portfolio is decreasing 78 or 22% per year. We determine this by equating the value of the base, in this case 0.78, with the quantity 1 minus r. The reason why we equate this value with 1 minus r as opposed to 1 plus r is because we are dealing with an exponential decay model. If this was an exponential growth model, then we would equate the value of the base with 1 plus r. Solving for r, we obtain 0.22, or 22%. This means that the rate of decay is 22%. In other words, the portfolio is decreasing 22% per year. Looking at the remaining options, we see that option 2 is a perfect match, so option 2 is a final answer. Regents Exam, Algebra I, August 2016, problem number 25. Graph the function y equals negative square root of x plus 3 on the set of axes below. In this problem, we are provided with the equation of a function along with a coordinate axis. We are asked to graph the function on the axis. We can accomplish this by setting up a table and generating a series of points by choosing appropriate values of x. These values represent the x-coordinate of the point. We then evaluate the function with these values to obtain the output or y-coordinate of the point. In the end, we connect the points with a curve. Notice that the function represents a radical function, particularly a square root function. Remember that the domain of square root functions are restricted to real numbers that make up the radicand, the variable expression inside the square root, greater than or equal to 0. So let's first determine the domain of the function by setting the radicand equal to or greater than 0 and solving for the variable x. Solving the inequality, we obtain x is greater than or equal to negative 3. This means that we should use values of x that are greater than or equal to negative 3. Typically, it is best to choose values of x that allow us to take the square root of perfect squares, like 1, 4, 9, 16, 25, and so on. This way, we can evaluate the function with relative ease. For this problem, let's evaluate the function at x equals negative 3, negative 2, positive 1, and positive 6. If we had more room, we could also evaluate the function at x equals 13, but the first 4 values are more than enough. Evaluating the function at these values, we obtain the following outputs. Now it is just a matter of plotting these points. Doing that, we obtain the following. The last step is to connect these points with a curve, as follows. Making sure we include an arrow on the right side of the function, indicating that the function continues in that direction beyond the plotted points. Notice that the leftmost endpoint of the function is a closed circle, since the domain of the function is restricted to values of x that are greater than or equal to negative 3. So we should not have any points plotted to the left of negative 3, nor should we have an arrow pointing to the left of negative 3. An alternative way of graphing the function is to make use of transformations. Recall that a parent function can be used to graph a transformed function. In general, a function can be translated up or down by adding or subtracting a constant to the original or parent function. In the same manner, a function can be translated left or right by subtracting or adding a constant inside the argument of the function. We can also flip the function across the x-axis by multiplying the original function by negative 1. In this problem, the parent function would be the function y equals the square root of x. This function represents an original untransformed function. Let's go ahead and graph this function by using the values of x that allow us to take the square root of perfect squares. In this case, we choose x equals 0, positive 1, positive 4, and positive 9. Next, we go ahead and start applying transformations. Notice that the given function has the quantity x plus 3 in the radicand. So this transformation is going to be a translation to the left of 3 units. Remember, transformations inside the argument of a function behave in the opposite way when compared to transformations that are applied outside of the argument. So we take every single point of the parent function and shift them to the left 3 units. Doing that, we obtain the following graph. The last step is to apply the transformation associated with a negative sign. This transformation will flip the graph about the x-axis. This transformation works by multiplying each y-coordinate of the function by negative 1. Doing that, we obtain the following graph. Notice that we obtain the same transformed graph. So either method will work. You can start from the parent function and apply transformations, or you can make a table and generate the points by evaluating the function at particular values of x. So this graph is our final answer. Regents Exam, Algebra I, August 2016, problem number 26. Richard is asked to transform the graph of b of x below. The graph of b of x is transformed using the equation h of x equals b of x minus 2 minus 3. Describe how the graph of b of x changed to form the graph of h of x. In this problem, we are provided with the graph of the function b of x. We are also given a transformed version of the function. We are asked to describe how the original function changed to form the new transformed function. We can solve this problem by analyzing the expression of the transformed function h of x. Recall that a function can be transformed to obtain a new distinct function by applying transformations. In general, a function can be translated up or down by adding or subtracting a constant outside of the function. In the same manner, a function can be translated left or right by subtracting or adding a constant inside the argument of the function. We can also flip the function across the x-axis by multiplying the function by -1. Or we can flip the function across the y-axis by multiplying the variable inside the argument of the function by -1. Taking a look at the transformed function h of x, we see that it has been transformed by subtracting 2 inside the argument of the original function b of x. This corresponds to a translation or shift of 2 units to the right. Remember, transformations inside the argument of a function behave in the opposite direction when compared to transformations that occur outside of the argument of a function. We also have 3 being subtracted from the original function b of x. This corresponds to a translation or shift of 3 units down. In the end, the new transformed graph has been translated 2 units to the right and 3 units down when compared to the original function b of x. So this is our final answer. Regents Exam, Algebra I, August 2016, problem number 27. Consider the pattern of squares shown below. Which type of model, linear or exponential, should be used to determine how many squares are in the nth pattern? Explain your answer. In this problem, we are provided with a series of squares that follow a predictable pattern. We need to determine the type of model, either linear or exponential, that can be used to predict the number of squares in the next iteration. We also need to explain our answer. We can determine the answer to this question by analyzing the pattern of squares. The first iteration of this pattern contains 2 squares. The second iteration contains 4 squares, and the third iteration contains 8 squares. We can determine the type of model this pattern follows by calculating the difference between successive iterations. From the first to the second iteration, 2 additional squares were added. From the second to the third iteration, 4 additional squares were added. If this pattern were to follow a linear model, then we should be adding a consistent number of squares. In this case, we should be adding 2 squares per iteration. At this rate, the third iteration should have a total of 6 squares and not 8. Since the pattern does not increase at a constant rate, we cannot use a linear model to determine the nth pattern. With that said, we can conclude that the pattern follows an exponential model, particularly 2 raised to the power of n, where n is a positive integer greater than 0. When n equals 1, we have 2 raised to the power of 1, which simplifies to 2. When n equals 2, we have 2 raised to the power of 2, which simplifies to 4. And when n equals 3, we have 2 raised to the power of 3, which simplifies to 8. So an exponential model is a perfect match since the pattern does not increase at a constant rate. So this is our final answer. Regents Exam, Algebra I, August 2016, problem number 28. When multiplying polynomials for a math assignment, Pat found the product to be -4x plus 8x squared minus 2x cubed plus 5. He then had to state the leading coefficient of this polynomial. Pat wrote down -4. Do you agree with Pat's answer? Explain your reasoning. In this problem, we are provided with the result and answer of a student's math assignment. We need to explain why we agree or disagree with the student's answer. The student found the product between two polynomials and then determined that the leading coefficient was equal to -4. Recall that the leading coefficient of a polynomial is the coefficient of the term that contains the highest power. When a polynomial is written in standard form, the term with the highest power will be the first term. It seems that the student had this in mind and selected the coefficient of the first term. The student's mistake was not writing the polynomial in standard form before deciding to choose the coefficient of the first term. As a result, the student stated the incorrect leading coefficient. So no, we do not agree with Pat's answer. The leading coefficient should be the coefficient of the term with the highest power. In this case, it should be -2 and not -4. And this is our final answer. Regents Exam, Algebra I, August 2016, Problem number 29. Is the sum of 3 times the square root of 2 and 4 times the square root of 2 rational or irrational? Explain your answer. In this problem, we are asked to determine if the sum of these two numbers is rational or irrational. We also need to explain our reasoning. Recall that the real number system is broken up into two sets of numbers, rational and irrational. A rational number is a number that can be written as a ratio of two integers of the form a over b, where b does not equal 0. Numbers such as 0, 1/2, -8/3, and -5 are examples of rational numbers. Rational numbers can also be written as decimals. For example, the number 2 can be written as 2.0, or 2.00, or 2.000. We can essentially add as many decimal places as we want. Usually, we just write the rational number as just 2, without any additional decimals. The rational number 1/4 can be written in decimal form as 0.25 or 0.250. Or we can continue adding zeros similar to the number 2, but usually we just write it as 0.25. The number 2 and 1/4 are examples of rational numbers that have a decimal representation that terminates. We also have rational numbers whose decimal representation does not terminate. For example, the rational number 1/3 has a decimal representation of 0.333, and so on. This pattern continues indefinitely, forever and ever. Instead of writing all of those 3's, we can just draw ellipses in the end, or draw a bar on top of the digit that repeats as follows. At times, certain rational numbers have more than one digit that repeats in its decimal representation. For example, the rational number 25/99 has a decimal representation equal to 0.252525, and so on. So we would draw a bar on top of the first repeating digits, in this case 25, since these are the digits that repeat. In the same manner, the rational number 763/9999 has the following decimal representation: 0.076307630, and so on. This one has 4 digits repeating indefinitely. An irrational number, on the other hand, is a number that cannot be written as a ratio of two integers. For example, the number pi and the square roots of non-perfect squares, like the square root of 5, are examples of irrational numbers. When we write the decimal form of an irrational number, we obtain a non-terminating decimal similar to a rational number. The only distinction is that the digits do not follow a predictable pattern, or have repeating digits like the rational numbers do. For example, the first 10 digits of pi can be written as follows. Likewise, the first 10 digits of the square root of 5 can be written as follows. Notice that there are no digits that repeat or terminate for either of these two irrational numbers. Returning to the problem at hand, we are asked to determine if the sum of 3 square root 2 and 4 square root 2 is a rational or irrational number. Since both expressions have a common radical expression, in this case, square root of 2, we can go ahead and simplify the sum by adding the coefficients of each radical expression. Doing that, we obtain 7 square root 2. Let's now use a calculator to rewrite this sum into its decimal representation. Notice that the decimal representation does not terminate, nor does it have any repeating digits. Therefore, this number is an irrational number. This means that this number cannot be written as a ratio of two integers. So this is our final answer. Regents Exam, Algebra I, August 2016, Problem number 30. The graph below shows two functions, f of x and g of x. State all the values of x for which f of x equals g of x. In this problem, we are provided with a graph of two distinct functions. We need to determine the value of x for which the functions equal one another. To figure this out, we're going to analyze the graph that is provided to us. Recall that a function is equal to another function at the values of x where the curves of the functions intersect. At this common point of intersection, the two functions share the same x and y coordinates, and therefore will be solutions to both f of x and g of x at the same time. Taking a look at the graph, we see that this occurs at two distinct points, one at the point -3, 4, and the other at the point 1, 3. So the values of x where both functions are equal to each other are x equals -3 and x equals +1. Alternatively, we can use function notation and say that f of 1 equals g of 1 and f of -3 equals g of -3. So this is our final answer. Regents Exam, Algebra I, August 2016, Problem number 31. Find the zeros of f of x equals the quantity x minus 3 squared minus 49 algebraically. In this problem, we are asked to determine the zeros of the function f of x algebraically. So we need to show our work as we find the zeros of the function. We can figure out this problem in two distinct ways. The first way is to set the function equal to 0, and then expand the binomial as follows. From here, we simplify the expression by collecting like terms. Next, we need to check if we can factor the quadratic expression. In this case, we need to find two numbers whose product is equal to -40, and whose sum is -6. Determining the numbers by inspection, we obtain -10 and +4. We now use these numbers and construct the factors of the quadratic expression as follows. Applying the zero product property, we obtain x equals 10 and x equals -4 as our zeros. We can also solve this problem by once again setting the equation equal to 0. But this time, instead of expanding the binomial, we isolate the binomial by adding 49 to both sides of the equation. We then go ahead and take the square root of both sides. The left side will simplify to positive -7, and the right side of the equation will be equal to x minus 3. Next, we solve for x by adding 3 to both sides of the equation. In the end, we have that x is equal to 3 plus or minus 7, which simplifies to two answers. In this case, x equals 10 and x equals -4. Either method will work when finding the zeros of this particular quadratic function. So this is our final answer. Regents Exam, Algebra I, August 2016, Problem number 32. Solve the equation below for x in terms of a. In this problem, we essentially need to solve this equation for x. Our final answer will have constants and variable expressions in terms of a. We first need to distribute the constant 4 into the binomial as follows. Next, we need to move all the terms that contains the variable x to one side of the equation, and everything else to the other side of the equation. Doing that, we obtain the following. From here, we go ahead and factor out the variable x from the terms in the left side of the equation. This way, we can isolate the variable x by itself. Now it is just a matter of dividing both sides of the equation by the factor that is left over. Doing that, we obtain the following. The last step is to simplify the numerator and denominator by collecting like terms. Doing that, we obtain the quantity 13 plus 3a over a. We can also rewrite this expression by distributing a to each of the terms in the numerator. Doing that, we obtain an alternative form of the answer. In this case, 13 over a plus 3. Either expression is an acceptable answer. So this is our final answer. Regents Exam, Algebra I, August 2016, problem number 33. The data table below shows the median diameter of grains of sand and the slope of the beach for 9 naturally occurring ocean beaches. Write the linear regression equation for this set of data, rounding all values to the nearest thousand. Using this equation, predict the slope of a beach to the nearest tenth of a degree on a beach with grains of sand having a median diameter of 0.65 millimeters. In this problem, we are given a set of data and we are asked to generate a linear regression equation. We are also asked to use the linear regression equation to predict the slope of the beach when the median diameter is 0.65 millimeters. In order to generate a linear regression equation, we need to use a graphing calculator and use the embedded statistics programs along with the data provided. The first step is to create a table or list with the first column representing the values of x, in this case, the median diameter of grains of sand in millimeters, and a second column representing the values of y, in this case, the slope of the beach in degrees. Once we input these two lists, we go ahead and use the linear regression program, sometimes referred to as linreg in some calculators. Using the linear regression program, we obtain the following equation: y equals 17.159x minus 2.476, after rounding each number to the nearest thousand. Next, we need to use this linear regression equation to predict the slope of the beach when the median grain diameter is 0.65 millimeters. So we evaluate our linear regression equation at x equals 0.65. Simplifying the expression and rounding to the nearest tenth, we obtain 8.7 degrees, and this is our final answer. Regents Exam, Algebra I, August 2016, problem number 34. Sean incorrectly graphed the inequality negative x minus 2y is greater than or equal to 8, as shown below. Explain Sean's mistake. Graph the inequality correctly on the set of axes below. In this problem, we are provided with a student's solution to an inequality problem. We are asked to determine the mistake that was made in graphing the inequality. We then need to graph the correct inequality. In order to determine the mistake, let's go ahead and solve the problem and compare it with Sean's answer. Let's first rewrite the inequality into the slope-intercept form of a line. So we first add x to both sides of the equation. We then solve for y by dividing both sides of the inequality by -2, making sure we flip the inequality symbol, since we are dividing by a negative number. Doing that, we obtain the following inequality. Next, let's go ahead and graph this inequality. The y-intercept is equal to -4, so we plot the point 0, -4. From here, we use the slope to generate a second point, so we will move 1 unit in the positive y-axis, and 2 units in the negative x-axis. Then, it is just a matter of connecting these 2 points with a solid straight line. Taking a look at the student's graph, we notice that so far we do not see any errors. The line of this inequality has been drawn correctly. Next, we need to either shade above or below the line. We can easily determine this by choosing a point and substitute it into the inequality, and check to see if we obtain a true statement. The easiest point to test, if possible, is the origin, so we test the point 0, 0. Substituting this point into the inequality and simplifying, we see that we obtain a false statement. This means that we shade the region below the line. Now we see where Sean made a mistake. Sean decided to shade the region above the line, as opposed to the region below the line. This error was most likely made because Sean forgot to switch the inequality symbol during the division step. So the inequality should be graphed with a solid line, and the set of numbers that satisfies the inequality will be those points below and on the line. So this is our final answer. Regents Exam, Algebra I, August 2016, problem number 35. A drama club is selling tickets to the spring musical. The auditorium holds 200 people. Tickets cost $12 at the door and $8.50 if purchased in advance. The drama club has a goal of selling at least $1,000 worth of tickets to Saturday's show. Write a system of inequalities that can be used to model this scenario. If 50 tickets are sold in advance, what is the minimum number of tickets that must be sold at the door so that the club meets its goal? Justify your answer. In this problem, we need to write the system of linear inequalities that models the scenario. We also need to determine the minimum number of tickets that must be sold at the door if 50 tickets are sold in advance. Lastly, we need to justify our answer. In order to find the system of linear inequalities, we first need to determine our variables and use the facts given in the problem to set up an algebraic relation between the chosen variables and the quantities given. We know from the problem that the drama club is selling tickets and the auditorium can hold a maximum of 200 people. From this fact, we know that the total number of tickets sold has to be less than or equal to 200. We also know that there are 2 types of tickets, those that cost $12 and those that cost $8.50. So we can use 2 variables to represent the quantity of each ticket. In this case, the variable x will represent the $12 tickets, and the variable y will represent the $8.50 tickets. So the first relation can be written as x plus y is less than or equal to 200. The problem also states that the club's goal is to sell at least $1,000 worth of tickets. This means that the monetary value of the tickets sold should be greater than or equal to 1,000. To write an algebraic expression, we take the number of each type of ticket sold and multiply them with their respective cost. In this case, 12x plus 8.5y should be greater than or equal to 1,000. So this is the system of inequalities that models this scenario. Next, we need to determine the minimum number of tickets that must be sold at the door if 50 tickets were sold in advance. For this scenario, we are told that the number of tickets that cost $8.50 is equal to 50. This means that y is equal to 50. We now need to use this value along with the linear inequality that models the cost to determine the number of $12 tickets we need to meet the $1,000 fundraising goal. So we substitute the value of y with 50 and simplify the inequality. Next, we go ahead and solve for x by subtracting 425 from both sides of the inequality. Then, we divide both sides by 12. In the end, we obtain x is greater than or equal to 48, after rounding to the nearest whole number, since we cannot sell a fractional portion of a ticket. The total number of tickets is also well below the number of seats that the auditorium can accommodate. So the club has to sell 48 $12 tickets in order to meet their goal. So this is our final answer. Regents Exam, Algebra I, August 2016, problem number 36. Janice is asked to solve 0 equals 64x squared plus 16x minus 3. She begins the problem by writing the following steps. Use Janice's procedure to solve the equation for x. Explain the method Janice used to solve the quadratic equation. In this problem, we have a student's initial steps towards solving a quadratic equation. We need to use the student's procedure and solve the equation for x. We also need to explain the student's method for solving the quadratic equation. Let's first analyze the student's method before we decide to use it to solve the quadratic equation. In line 1, the quadratic equation is copied. In line 2, a coefficient and the variable x is replaced with the variable b. And in line 3, the new quadratic equation in terms of the variable b is factored. The next step would be to use the zero product property and set each factor equal to 0. In this case, we set the quantity b plus 3 equal to 0 and the quantity b minus 1 equal to 0. We then solve for b in both of these linear equations. Doing that, we obtain the following. Notice that the problem is asking us to solve for x and not b. We need to replace the variable b with an expression in terms of x. By comparing the equations of line 1 and line 2, we can determine the variable expression for b. Notice that the linear term in both equations from line 1 and line 2 must equal to each other. The quadratic terms should also equal to each other. Equating the linear terms with one another and solving for b, we obtain b is equal to 8x. We can now substitute this expression for b into both linear equations as follows. Finally, we can go ahead and solve for x. Doing that, we obtain x equals -3 over 8 and +1 over 8 for the solutions of the quadratic equation. Next, we need to explain the student's method for solving this quadratic equation. The student essentially substituted b for 8x in both the quadratic term and linear term of the equation. Notice that 64x squared can be written as the quantity 8x squared. When b is substituted for 8x, we obtain b squared. Likewise, the linear term 8x gets replaced with b. By carrying out these substitutions, the quadratic equation is rewritten into a much simpler form, allowing the student to factor the quadratic equation in terms of the variable b. Once factored, the student then solved for x by substituting back the value of b with 8x, which can then be solved to obtain the solutions to the quadratic equation. So this is our final answer. Regents Exam, Algebra I, August 2016, problem number 37. For a classic picnic, 2 teachers went to the same store to purchase drinks. One teacher purchased 18 juice boxes and 32 bottles of water and spent $19.92. The other teacher purchased 14 juice boxes and 26 bottles of water and spent $15.76. Write a system of equations to represent the cost of a juice box, J, and a bottle of water, W. Kara said that the juice boxes might have cost 52 cents each, and that the bottle of water might have cost 33 cents each. Use your system of equations to justify that Kara's price are not possible. Solve your system of equations to determine the actual cost in dollars of each juice box and each bottle of water. In this problem, we need to write the system of equations that represents the cost of the items purchased. We also need to show that a particular price for the item bought is incorrect and not possible. Lastly, we need to solve the system of equations to find the true cost of the items bought. Let's start by writing out the system of equations. Using the facts of the problem, we know that our variables are going to be the price of the juice box, J, and the bottled water, W. We know from the problem that the first teacher bought 18 juice boxes and 32 bottles of water. The teacher ended up paying a total of $19.92. So if we take the number of each item bought and multiply each item with their respective price, it should equal $19.92. A second teacher also purchased 14 juice boxes and 26 bottles of water and spent $15.76. Similar to the first equation, we take the number of each item purchased and multiply them with their respective price. The total should equal $15.76. So this is our system of equations. Next, we need to show that the juice boxes and the bottles of water did not cost 52 and 33 cents respectively. We can prove this by contradiction. Let's assume that a juice box and a bottle of water did cost 52 and 33 cents respectively. Then, these prices should satisfy the system of equations that we wrote in the previous step. Substituting these prices into the first and second equation should yield a true statement for both equations. Substituting the prices and simplifying, we obtain the following. Notice that the prices yielded a true statement for the first equation, but not for the second equation. Recall that a solution to a system of equations needs to satisfy both equations and not just one. Therefore, the prices that Kara suggested are incorrect. The final question is asking us to solve the system of equations to find the actual cost of the items. We can solve this system by graphing the equations or by using the substitution or elimination method. Let's go ahead and solve this system by using the elimination method. For this method, we first need to choose a variable to eliminate. Usually, the variable that has the smallest coefficient is the best variable to eliminate. In this case, let's eliminate the variable j. In order to eliminate this variable, we need to multiply both equations by a constant so that the coefficients are additive inverses of one another. Notice that the numbers 18 and 14 have 2 as a common factor. This means that we need to multiply the first equation by 7 and the second equation by 9 in order to obtain a common coefficient, in this case, 126. We also need to make one of these constants negative. So let's make the constant 7 negative. Keep in mind that we are free to choose which constant becomes negative. Multiplying the equations and simplifying, we obtain the following. Next, we go ahead and add the equations together. Notice that the variable j is eliminated, leaving us with an equation with a single variable. In this case, w. Solving for w, we obtain 0.24. The last step is to substitute this value into one of the original equations and solve for the other variable, in this case, j. Substituting the value for w into the first equation and solving for j, we obtain 0.68. So the price of the juice box was 68 cents, and the price of the bottled water was 24 cents. So this is our final answer.